we're from Chandler High School, CC Robotics. I'm not sure what.
Okay, so our robot works off of 3 motors, 2 for forward, backward, and 1 for up and down.
And they're 750 gallon per hour Billish motors.
We have 2 cameras for viewing, 1 main camera on top and 1 underneath for guidance and making it more accurate. Our control systems are old recycled FRC controllers, that 1 in here and 1 up there for controlling using the 2 joysticks. Okay. So we have it set up through programming so that 1 joystick controls the 2 forward and back motors, so that it's programmed so we can do all directions on the X and Y axis through 1, and then we have the Z axis, which is up and down through the other.
We have holes in our frame so that water can seep inside. We have holes at the top and at the bottom so that the whole frame will fill and there will be no bubbles on the top.
So the frame is essentially for support, and it supports our watertight case here, which houses our electronics. And this is polypropylene plastic that has been plastic welded together. We did the wedge shape so that it has less surface area than a box would, and it would have less pressure on it. We did like you would for a submarine, where you do pressure. The combined pressure of this seals our rubber seal on the underneath here. We have a seal that we put in, and then we house all of our electronics, and then to have the wire come out the back, we have strain reliefs, watertight strain reliefs that are IP68 watertight.
So you actually got strain reliefs themselves that are watertight?
Yes. Yes. We researched and found these are Lap Cable brand, and we got them donated from Lap USA.
Do you have those listed in your technical report?
Probably not.
Because that might be one of the best technological contributions from your team. Might be those, because teams have been, they're paying for watertight connectors that I'm assuming 20 times the cost of what you guys are doing with the strain reliefs.
They were donated.
Yeah, and well, then the problem is this cable itself watertight? So to power all of this with the least amount of wires coming out of it, we're using this 3 twisted pair, which is it's Belden cable. So for our tether, we have 2 tethers. Each of these is 3 twisted pairs inside of this. So we have 12 wires going up to the surface, and then to power all of our motors and cameras, we have another 18 wires coming out, but they're in these, so this is easier to watertight than individual wires coming out. So, but then to keep those from leaking, we did adhesive heat shrink, and it seals it all up on each end.
It makes it circular, so we stick a piece here, and we close on it, so it's a perfect circle.
And then also on the ends, we seal up all the wires with it.
Why don't you go ahead, by the way, and introduce your team members.
Okay. Go ahead.
So, Gerard?
I'm Gerard Pales, and I just finished 9th grade. This is my first year program.
What are you working on this year on the robot?
I did the hydrophone, and I just worked all around where they need me.
Okay.
I'm Mike Brickup. I'm going to be a sophomore this year, and I did web programming, and I did some of the robot programming.
Hi, my name is David Calvin. I'm going to be a senior next year. I did the programming for the robot, and I just helped with the jobs that I was needed.
I'm Roberto Barosio, and I'm going to be in 10th grade, and I just helped with it.
My name is Ian Mason. I graduated last month, and I did most of the I tried to go out and get donations for us, and had this box made from a company for us, and generally tried to get things done.
Hi, my name is Selena Mancera. I'm the president, and I dictated it.
My name is Enrique Canedo, and I worked on mounting the cameras and drilling holes and gluing the frame together.
Hi, I'm Josh Williams, and I'm the vice president for the robotics team, and I pretty much helped where I could.
Are there other team members that didn't make it?
Craig.
And Jacob.
There's a couple.
Okay.
Most of your team, just Mike?
This is most of it, yeah.
A couple more?
So, Gerard, why don't you speak of how you made the hydrophone?
Well, okay. So the hydrophone is normal computer microphone, just the
Well,
guts.
where is it?
This is our hydrophone, and so we use PVC and we capped both sides, and so the idea was we would use mineral oil and just like a floaty to like hold the microphone in place, and then so the sound waves would go through the solid PVC and then hit the mineral oil so that it would be watertight and wouldn't ruin our microphone. And so then we took a normal eighth inch jack and connected the end of the microphone wire. So that's how it works.
So that's to hear.
Here,
Just-
Messy cry.
This cry. And some of the other mission objectives, they're not on here right now, but we have torpedoes that we've made. We got clear pipe, basically, hard plastic pipe, and we used CO2 cartridges, the refill or the one-time use CO2 cartridges that you use to like fill up bike tires and that sort of thing. And we put them in a nozzle in the end, and then in the front side there is the tracking device, and then there's a magnet on the front to stick to Nessie. And so to puncture that, we have it in the back. We have a tube, a PVC pipe that holds it, and in the back we have a Bimba cylinder that's sharpened, and it punctures it and opens it up and shoots off, and it goes about 12 to 20 feet
In the water.
in the water. So that's 16 grams, so it's pretty low. And then
Both our cameras are color. One is aimed towards our hook here, and one is aimed for you.
And the cameras, the one underneath is Lights Camera Action camera that we had donated a couple years ago, and this one we made by sealing it with what's that? A union, that's PVC union with a glass in front. And then for lights, we have LEDs on the front that are in casting resin to be waterproofed.
We also have these weights in order to balance the weight, and we have some on the inside of the tubing also. Towards the bottom.
So,
How much water time do you have?
of testing,
Yeah. Well, how much time robot in the water?
probably 2 hours total.
Yeah.
Okay. You got it neutrally buoyant?
Yes.
Yeah. And
'cause,
it's sealed completely watertight.
this bottom frame section here is filled with pipe, and so is this H frame that holds up this box.
You
along
say
with these
pipe,
two
you mean
boxes.
rebar?
Yeah.
It's like just